Hi everyone. So this is the second part of learning machine learning. In the first part we discussed about semiotics, the definition of meaning, origin of number system. We developed statistics, what it is, mean, median, mode, variance, all those stuff. Then we developed an intuition about what is coordinate geometry, and this is nothing but another way of looking at the numbers. And we also looked into why visual learning works for human, and we touched upon on the mapping. This video is mainly going to be about algebra, continuous versus discrete math, mapping, functions, linear versus non-linear transformations, tuples, vectors and matrices. So after this video you will have a very good understanding of what are these topics and what do they actually mean. Yeah, so let's start with algebra. So in the last video we talked about numbers. So we have like a set of numbers like 1 2 3 4 5 6 7 8, right there, right? 3 4. We had a reading of temperatures. If you remember, we had a reading of temperatures, right? So these were the set of numbers, and these were the colors, and we had a mapping like this. Then we also saw that this mapping can be represented like this is basically related to set. Now algebra basically talks about variables which are like placeholders, and these concepts whatever I am teaching related to math, all of these will be used in your coding. So we'll do some kind of coding exercise also today. Very small, very basic codes. And as we progress, as you guys go through this series, you will learn a lot about coding as well as mathematics behind machine learning and AI. What do I mean by placeholder? So let's say uh, someone has uh, x amount, someone has let's say 10 rupees in his account, and tomorrow he has let's say 20, and next day he has 30 40 like that. Now based on these amount, let's say he is getting some kind of interest, and that interest is let's say 2%. Now if I ask you how much money does he have at a particular amount of time, what you will do, you will basically do 40%, let's say 40 rupees on the fourth day. So 40 rupees on that day he earned basically 2% of this, right? 4 3 8, 8 rupees. Now uh, if I ask you in general that how much money will he have on let's say nth day. Now, when I am talking about n, this n is a placeholder. It is talking about a variable, something which is not defined yet. It could be 1, 2, 3, 4, a number of days. So, we, we basically represent these things as a variable. And these variables, this variable can be something like this, 10 into n, right? So, this is a variable which talks about how much profit or interest he will have on nth day. So this is basically a placeholder. In general, in mathematics, we start with the unknown. This is just a placeholder convention that we follow. We represent it like x. X is an unknown, or an or unknown or input basically, and output is generally represented as y. Got it? So all of these handling variables, maths which deals with variables, that mathematics is known as algebra. Very simple definition. So wherever you see some variables like x, y, x1, x2, all of those things deals with algebra. Algebra is nothing but a math of dealing with placeholders, and in computer science we call it variables. Cool. Now that we have some idea, I'll also quickly give you an example of another uh, example. So if I see a mathematics or a symbol representative which says something like is equal to, let's say, 200, this is related to algebra, where we are basically using a variable x, and here we can solve it and find the x value. Okay, so this is basically algebra. Now, continuous and discrete mathematics. This is a very crucial thing which we need to understand. When we were talking about number system, we had, and when we derived statistics out of it, we had a set of defined numbers. Those set of numbers were like this, something like this. So here we are dealing with discrete numbers, right? A set of numbers are defined. So the math is not continuous. If I am representing these points visually, if I'll tell you, these are the discrete points. What do you mean by discrete? These are discontinuous set of points. But if I have something like, since we already know algebra, let's say there is a relationship which is defined like y is equal to 4x plus 10. Is it talking about continuous mathematics? Is it dealing with continuous mathematics or discrete? So you will say it is continuous. Why? Because for every set of x value, there is a y. There is a mapping. For x, there is a y. If I'll ask you for 0.5, what is the value? You will get one value. For 0.2, for 1, 2, anything. So the domain is basically, which we talked about, the domain is here minus infinity to infinity, and the range is also infinity to infinity here, but minus infinity to infinity. Yeah, so basically this is how this will just keep in mind why continuous and discrete mathematics I'm emphasizing on this part, because when we will do hypothesis modeling for a linear regression model or any transformations, we will basically come up with a hypothesis which will represent a continuous mapping, even though the data points we will have of discrete. Those discrete dataset input points will be there. Okay, perfect. Now these two are done, we'll talk about mappings. So in the last video we talked about one set of numbers when they are mapped with another set of numbers. This was basically mapping. So what is linear mapping and what is nonlinear mapping? There are two ways in which we will basically represent these things. One could be, not just two ways, basically three ways. One is basically set. This is like set representation. Another we do is visual, which is related to coordinate geometry when we plot the numbers like this is one mapping, like that. And another representation is algebra. Okay, where I will define something like y is equal to 2x plus 3, y is equal to 5x square plus 2x plus 90. Okay, note all of these things are talking about the same thing. We knew that numbers represents something which we observe. We use numbers to represent those things. In the last video I talked about the temperature readings. It could be humidity, it could be money in your bank account, it could be any physical observation or non-physical also, right? Anything which you observe, we use numbers to represent them. But we also noticed that there is a cause, what do you say, uh, cause and effect relationship. So it could be something like uh, if the money in your account is 10 rupees, you will get 2 rupees as interest. So there are some underlying hidden variables which is determining the output. So the mapping which we talk about the functions or mapping. All of these things, by the way, represent the same thing. We are talking about functions and mapping. Okay. Now, we noticed, or we basically, uh, now the question is, what is a linear mapping and non-linear mapping? The linear mappings are the ones which has the input variables with the power 0 or power 1. So here this is a linear mapping because the input has a power, the highest degree is 1. Here also, and there is no crossover also. So currently, for the sake of easiness, I am keeping only one input variable. It could be n. Here the highest power is 2. So this is a non-linear mapping. In terms of visuals, if it's a straight line or the transformation is like that, it is a linear mapping. If it is a curved, it is non-linear mapping. From here, can I say linear, non-linear? It is very difficult. So let's talk about this. Let's talk about this first. This number line is there, right? Now think of another number line similar to this. Let's just start with this number line only. We have 1, we have 2, we have 3, we have 0, -1, -2, like that. Now think of someone applying a force. Okay, think of these things as forces that is applied on that number line, and these number line will now shift. So this thing might get shifted here, this thing might get shifted here, this thing might get shifted here, like that. So if you draw like this is how the mapping happened. Why I am telling you like this is because there is no other way of for us to actually grasp the concept of linear and non-linear mapping apart from visually understanding it. When this transformation happened, notice the difference between these points always remained same. And no, when I say same, I don't mean same by unit. I mean, like if it was 0 to 1 was 1 unit, it could be, let's say, 5 unit. But here to here, if it is 1, this will be also 5. If this was 1, this will be 5. So what I'm talking about here, the delta x and here the delta x dash, that ratio will remain constant. That mapping is known as linear mapping, is equal to constant. This is the linear mapping. Dekho, you need to think like take a rod or not rod, a rubber pipe where you have your initial coordinate system like 0, 1, 2, 3, 4, like that. Put red dots on that. Now apply forces on both sides, like left and right, do anything. Once you have applied forces, all of those individual points will get shifted. Let's say those are transformed. You don't know currently where it is. Now after the transformation, what you will do, you will basically put it against the initial points, and you will see, for example, if the distance between 2 to 1 was 1 unit initially. How much is it right now? 2 to 1, let's say it is now. So initially, let's say it was 1 meter. After the transformation, it has gone to like 10 meter. What is the uh, uh, how the transformation has happened for 3 to 4, how the transformation has happened for -1 to -2? All of those things, when you will consider, you will realize if this delta x by delta x dash is equal to constant, this is a linear transformation. Does that make sense? Am I making sense? I hope this is understandable. You had a rubbery, stretchy number line, you stretched it, or you pushed it in one direction or another direction. From people who are from mechanical background might be able to understand that this is basically related to a elastic body, basically transformation, where you have a very continuous elastic body, you stretched it, and after stretching, the distance between those 2 points and the ratio of the distance which was earlier, that remained constant. So, and if you observed that, let's say this point got shifted here, and this point got shifted here, while this got stretched here and this got stretched somewhere here, then you will see this delta by this delta and this delta by this delta is not constant. So then it will be a nonlinear transformation. From coordinate geometry point of view, you will, even though we are doing this mapping which is related to this set mapping, visually if you will represent, if this x and this transformation, after this transformation, if I represent those point here, if that transformation is making a straight line, this is a linear mapping. But if the transformation is making something like this is a nonlinear mapping. And why it is, uh, why I am confident this definition is not corrupted, because see, for a straight line, the representation is really y is equal to mx plus c, or this y2 minus y1 will be, and x2 minus x1, the ratio of these 2 points at any 2 point, if you will calculate, that will be equal to this m. So this will be constant. This is also known as slope or tan theta, which is y by x. I hope this helps you understand like linear versus non-linear transformation. Whenever the stretching is happening, and if you'll also think uh, from grid line point of view, this is how, if this is linear transformation, the grid will become like this. The initial grid was like this, horizontally orthogonal. Right now it is this. Okay, yeah. Vectors and matrices we'll talk about, or these two concepts are similar, which is basically when you have something like there are two variables on which the input output depends. So it could be like, let's say x1 and x2, which is related to y1. So not y1, y. So two input variables are deciding one output variable. Then you came up with a scenario where you had three underlying variables. So these numbers started becoming longer. So what mathematicians came up with an idea, okay, hey, instead of writing like this, what if I represent those numbers like this? And this is nothing but a vector, nothing else. कोई extra mathematics, कुछ extra concept नहीं है. This is very simple. x1, x2, x3, these are the input variables, and there is just one y which depends on this, and this relationship is what is known as function. So function is something which takes an input x and maps it to a y. I hope till this point everything is clear. So we talked about basically algebra, we talked about continuous discrete mathematics, vectors, and Now we'll do some kind of coding. Let's start with simple. This is the same slide what we talked about, index.js. I hope everyone is comfortable with any programming language. We'll start with simple, what we talked about, variables. In Node.js, we represent variables with any name which you want, and there are three types of parameters, not parameters, the let, const and var, but we'll deal with those things later. But let's say I start with something like let x is equal to 10, and there is a way of printing it, which is console log x node index.js. That's how you run it. Okay, so this is our first program where we created a variable and we logged it. And next we should know how to write a function. So we'll write const f my function, and how we'll define it, we'll define it something like this. It takes a variable x and it returns something like 4 into x plus 10. Okay, and then we will call the my function of 10 and we will log it. Cool. So 10 into 4 is 40 plus 10 is 50. This is fine. This is again, this part is dealing with a continuous function. This is a discrete point we are talking about. This is a point and this is a variable. Perfect. So far so good. Let's comment this out. Let's keep it here. In the next video we'll talk about code related to data set generation, and we'll talk about calculus, and we'll do linear regression. I think we have now very good understanding of fundamentals that we need to understand the concepts of linear regression, what it is, what we are trying to find, and how do we use calculus to find these model of fitting, which is basically a fitting problem. It's a standard curve fitting problem. Cool. I hope you guys liked it. I will check in all of these things and hope to see you guys in the next video. We invented the, so in the first we talked about semiotics, numbers, we talked about visualizing the numbers, we invented the number line, we invented the 2D 3D world. Today we talked about functions, we talked about algebra, mapping. Third video will be visualization, calculus, and coding linear regression. Post that we'll go ahead with coordinate, gradient descent, polynomial fitting, feature engineering, scaling of data, how it is important, all of these things in the next. And in the 14th we'll talk about nonlinear activation and universal approximation theorem. Till this point I think you guys will have a very good idea about basic fundamentals of machine learning. Then we'll jump into other concepts. Cool. Thank you so much. I hope you guys liked it.